Good afternoon, students. Today we will discuss about third unit, water pollution. Already we completed first two units. Next, third unit, water pollution. It is very important chapter. So before we are going to discuss about water pollution, first we discuss about the physical properties and chemical properties of water. We know that water is very essential for our life. Means no animal or plant can exist without water. So that's why it is very important factor for life. Next, major part of all living organisms are made up of water. In our living organisms, means animals, plants, they are made up of water only. For example, if you take a human being's blood contains nearly 90% of water. So that's why our body mainly made up of water. Not only for life, it is also a very important factor for growth of plants and animals. If you observe the plants and animals, they will grow they will grow by taking the water as a main component. Next, if you observe the water, it covers the earth 3/4. 3/4 of the earth is covered by water only. Next, purest form of water is rainwater. We know that from rainwater only we will get a pure form of water. Next, nearly 1.4 billion cubic kilometers of water is present in the hydrosphere. So environmental segments we discussed in earlier classes. In that classes I told you hydrosphere. Hydrosphere means the total water which is present on the earth is called hydrosphere. So in the hydrosphere nearly 1.4 billion cubic kilometers of water is present. Out of 1.4 billion cubic kilometers of water, nearly 97% of water is present in the sea. Means it has 97% is present as a sea water. Remaining only 3% only exist as a fresh water. So if you take 100% of water, 97% of water is present in the seas. Remaining 3% of water exists as a fresh water. So out of these 3% of water, nearly 77.2% of fresh water is present in the polar regions as a ice caps and glaciers. So nearly 77.2% of water is present in polar regions as a ice caps, means present as ice, and a glaciers means pieces of ice. So remaining 22.4% of water is present in underground water. The underground water present as a 22.4%. So remaining 0.36% of water is present in the lakes, rivers, and also swamps. Swamps means always wet areas, or we can also say marshy places, means dirty places which is present on water. So these are the distribution of water. This is about the distribution of water. Once again, hydrosphere contains 1.4 billion cubic kilometers of water. Out of 1.4 billion cubic kilometers of water, 97% of water present in the seas. Only 3% of water present as a fresh water, means what we are using that water. So out of 3% of fresh water, 77.2% of fresh water is lodged or present in the polar regions as a ice caps or glaciers. 22% of 22.4% of present in the underground water. Remaining 0.3% of water is present as a present in the lakes or rivers and also swamps. Swamps means I told you always wet areas. So these are the distribution of water and introduction for water. Next, if you observe the physical and chemical properties of water, first you see physical properties of water. So water generally, if you observe the water is a colorless and tasteless and odorless liquid. We know that. So pure water do not contain any taste, any color, any odor. Odor means smell. So no smell, no color, no taste for pure water. So that's why it is a universal solvent. So most of the substance will dissolve in the water, so that's why it is called as a universal solvent. Next, if you observe the first property of water, molecular mass or molecular weight. So the molecular weight of water is 18.015 gram per mole. If you take 1 mole of water, the molecular weight of water is 18.015. The molecular weight 015 grams. Next, melting point. Melting point in Kelvin scale 273 kelvins, in Celsius scale 0 degrees Celsius. Boiling point 373 kelvins, or in Celsius scale 100 degrees Celsius scale. Density. If you observe the density is 1 gram per centimeter cube. 1 gram per centimeter cube. Next, viscosity. Water viscosity 0.8903 centipoise. Centipoise, that is the units for viscosity. Next, specific heat is, water specific heat is 1. Water specific heat is 1. Like this way you can observe the some more properties, especially water in the condensed state. Condensed state means either liquid state or solid state. In these two states, water exhibit abnormal properties. Abnormal properties means water shows general properties at a particular temperature, but in the condensed state, means in the solid state or liquid state, the water exhibit different properties because the presence of intermolecular hydrogen bonding in the water. So hydrogen bonding, we know that. So hydrogen bond means intermolecular hydrogen bonding means the hydrogen bonding which is formed between the two water molecules is called intermolecular hydrogen bonding. It is mainly observed in water or some substance like alcohol in water. Like that substance, whenever dissolved in the water, they form hydrogen bonding. It is again divided into two types. We know that intermolecular hydrogen bonding and intramolecular hydrogen bonding. Inter means between the molecules the hydrogen bond will form. Intra means the hydrogen bond form in a molecule. Next, one more important property, water is more denser than ice. If you compare the density of water and ice, which one is more denser means water only. Water is more denser than ice. So that's why ice will coat on water due to this reason. So these are about physical properties. If you come to chemical properties, so water can interact with a large number of substances under various conditions. So in different conditions, water can react with different substances. So that's why it is called universal solvent. Already I told you that why we are calling it universal solvent. Many substances will dissolve in the water or interact with water. So that's why it is called universal solvent. So first property, amphiprotic nature. Amphiprotic nature means water both exhibit or act as a both Bronsted acid when it is dissolved in the alkalis and Bronsted base when it is dissolved in acids. So water has a dual nature, either acidic nature and basic nature. When it is dissolved in the acids, it acts as a base. When it is dissolved in the acids, it acts as a base. Like that way, it shows two types of property, two types of nature, both acidic nature and basic nature. This nature is called amphiprotic nature. For example, if you see sodium oxide, it is a metallic oxide means base. When not dissolved in the water, it forms sodium hydroxide. So here in this reaction, what we will observe, sodium oxide whenever react with water, water can donate 1 H plus ions to sodium oxides. So whenever it donate 1 H plus ions to sodium oxide, it will form sodium hydroxide. So Bronsted acid means the substance which gives H plus ions is called Bronsted acid. Bronsted base means the substance which accept H plus ions is called a Bronsted base. So like this way, water can exhibit both acidic nature and basic nature when it is dissolved in acids and bases. Next, second one, reaction with non-metals. Second one, reaction with non-metals. If you observe the reaction with non-metals, especially non-metals means, for example, if you take halogens, for example, if you take halogens and carbon, halogens means 7th group elements, pure non-metals, and carbon also pure non-metal. Whenever these non-metals are react with water under suitable conditions, they form hydrogen gas and oxygen gas along with halides. For example, if you take a X2 means either fluorine or chlorine. Whenever we react with water, they form 2HX. HX means hydrogen halides plus O2. Oxygen gas also will release in the reaction. And one more, for example, carbon. Whenever carbon react with water, it will form CO plus H2 under suitable conditions only. This reaction is not take place at normal conditions. Under suitable conditions only these reactions can take place. For example, carbon whenever react with water under suitable conditions, they form CO and hydrogen gas. The third one, reaction with basic oxides. So strong electropositive metals whenever react with water, they form basic oxides. So when the strong electropositive metals, so metals are generally basic in nature, so that's why, so whenever strong electropositive metals means strong bases, so whenever react with water, they form basic oxides. For example, I already told you Na2, sodium oxide. So whenever sodium oxide react with water, they form sodium hydroxide. It is a base. So like this way, water whenever react with strong electropositive elements, they will form bases or metallic oxides. Next, fourth one, reaction with acidic oxides. So when non-metallic oxides means acidic oxides. Non-metallic oxides are called acidic oxides. So whenever these acidic oxides dissolve in water, they form acids. So basic oxides whenever dissolve in or react with water, they form bases. Whenever acidic oxides or non-metallic oxides react with water or dissolve in water, they will form acids. For example, SO3, sulfur trioxide is there. Sulfur trioxide whenever react with water, it will form H2SO4 means sulfuric acid. Like this way, Cl2O7 means hypochloride. Whenever react with water, it will form hypochlorous acid. Hypochloride oxides whenever react with water, it will form hypochlorous acid will form. Next, fifth one, photosynthesis. So in photosynthesis also, water can react with CO2 in the presence of sunlight. It will form carbohydrates. In photosynthesis, what happens? Water react with CO2 in the presence of sunlight, and also chlorophyll give carbohydrates and oxygen gas. So like this way, water can react with CO2 in the presence of sunlight in photosynthesis reaction. These are about chemical properties of water. Next, water quality. It is the second question of our unit 3. Next, water quality. So to determine water quality, we have some parameters and norms. So those parameters are given by US PHS, means United States Public Health Standards, and also ISI, Indian Standard Institution. So by these two organizations are given some parameters to determine the water quality and also some criteria. So which criteria describe water quality? Some physical and chemical and biological characteristics of water will determine the quality of water. So water quality is mainly depend on physical and chemical and biological characteristic of water. Physical and chemical biological characteristics are very important to determine the quality of water. So some norms are there. Those norms are should follow to determine water quality. Before we are going to that norms and parameters, first we will discuss some physical and chemical and biological properties of water. For example, if you want to determine the water quality for fresh water, first we should take some chemical properties. For example, pH. Take a pH. Physical properties means generally color of water, color, taste, and also odor. All these are physical properties. Turbidity, these are the physical properties of water. If you take chemical properties means pH of chemical, pH of water, like this. Chemical properties means pH, next TDS, total dissolved solids, TSS, total suspended solids, alkalinity, salinity, next hardness. All these are chemical properties of water. Next, biological properties means nothing but bacteria, protozoa, algae. So these are the factors of biological characters of water. So when we observe these three characters of water, we can determine the quality of water by comparing the parameters with which are given by the USPHS and also ISI institution or organization. So once we will discuss about one by one. For example, chemical properties. If you take chemical property pH, you will know that pH means it is the negative logarithm of hydrogen ion concentration. pH means negative logarithm of hydrogen ion concentration. Next, it's mainly we will observe or we will measure the pH by the device, glass electrode or otherwise pH meter. We can measure the pH of water using glass electrode or pH meter. So pH of natural water mainly contain the ranges or mainly contain the values 3 to 10. Which if you observe the natural water means a canal water or bore water, like that water if you take in the pH meter, it shows the reading in between the range 3 to 10. But most of the cases the water has a pH between 6 to 9. So generally if the pH value is 7, that is indicate neutrality of the water. So means water is neutral in nature. No, water should be neutral in nature, either acidic nature or basic nature, are not suitable to drinking purpose or consumption purpose. So that's why water should be has a pH exactly 7. So if the pH value 7, the water has a neutral nature. This is the suitable water to consume or to drink water. Next, the main contribution to increase the pH or to increase the basic nature in the water, mainly presence of bicarbonates, carbonates and hydroxides, along with phosphates, silicates, ammonia, etc. Whenever water contains any bicarbonates, regarding about bicarbonates, means calcium bicarbonate, magnesium bicarbonate, like that, and also carbonates, calcium carbonate, calcium magnesium carbonates, like that way hydroxides, sodium hydroxide. Whenever these are present in the water, they increase the basic nature of water. Like that way, the water nature is depend on all these chemical substance. So this is about pH. So pH is exactly 7, that indicate the neutral nature of water. pH is less than 7, that indicate acidic nature. pH is greater than 7, that indicate basic nature of water. Like it way we can observe the nature of water by using pH. So based on pH values we can determine the water nature. Next one, second property, suspended solids. So whenever another important chemical property of water is suspended solids. So it is simply indicated by TSS. Simply indicated by TSS. So it mainly measured by using filtering and weighing. So whenever we measured, if you want to measure pieces in TSS, total suspended solids, we can filter the water and we can remove those suspended particles and we dry in the sunlight and we can weigh it. By using that filtering and weighing, we can calculate suspended solids in the water. Or one more important method to calculate suspended solids, turbidity of sample. So by using turbidity nature, whenever these substances, whenever some substances are present in the water are not in clear nature, means not in clear form. It is observed in cloudy nature. Cloudy nature means seems to be just like a turbidity, that is called turbidity nature. So that's why presence of some substance, water has a turbidity nature. Due to that turbidity nature, we can observe that water is not in a good quality. So by measuring that turbidity also we can find out the suspended solids. Or one more method, we can also use Doppler method. Doppler method also can use to determine or find out the suspended solids in the water. Next, naturally whenever water flows on the over the earth surface, so whenever it flows from over the earth surface, some salts which are present in the earth are dissolved in the water and they can settled or they can suspended in the water. So when the water flows on the earth, some salts like calcium or magnesium salts are dissolved in the water or suspended in the water. Along with these also, some more particles like for example colloidal particles, means sand particles or clay particles or dust particles are comes into the water. These may be settled in the bottom of the water or maybe float in the water, means suspended in the water, because based on the size of the particles. For example, if they have a particle size 0.5 millimeters larger, they can settle in the water. Whenever water flow decreases, or otherwise when the particle size are less than 0.5 millimeters, they can be suspended in the water. Like this way, we can observe the some suspended particles in the water whenever water flows on over the earth surface. Natural suspended particles, what we are observing in the water is mainly soil minerals. So some minerals are when dissolved in the water, those are called soil minerals. Next also colloidal particles, just want to tell clear sand particles. These particles also will observe in the naturally we will observe in the water. And also some metal ions. So generally ores are present in the earth, so those ores will dissolve in them, maybe dissolve in the water, and so that's why some metal ions also are present in the water, along with some cations also. Cations also positively charged ions also present in the water. These are natural suspended particles, but some anthropogenic sources of suspended particles also present in the water. Anthropogenic means man-made suspended particles. For example, if you observe the municipal sewage or municipal drain water, some organic matter comes into the water. Like that way, some inorganic substance also will comes into the some industries as a fly ash and also cement dust or iron oxides, etc. Some municipality sewage water contains some organic matter, and also some from some industries some fly ash, cement dust, next iron oxide, all these are comes into the, these are also been suspended in the water. So these suspended water, particles can measure by either Doppler methods or maybe filtering and weighing methods. So the most accurate method for this suspended solid particles is filtering and weighing method is most accurate method to determine suspended solid particles, total suspended solid particles. Next, if you want to determine the water quality, we need or we should compare some parameters which are given by USPHS, United States Public Health Standards, and also ISI, Indian Standard Institution, ISI. So we'll see those parameters. If you have those parameters in the water, that is calculated as a good water. Otherwise, if the parameters are not present in according to these values, that the water is a polluted water. So these are main important parameters. First one, see parameter: color, odor, and taste. So according to USPHS and also ISI, it should be a colorless, odorless, and tasteless. The water should be colorless and odorless and tasteless. Some parameters ISA values are not observed because it is not given for those parameters. But USPHS has a total values for those parameters. So that's why some parameters don't have ISA standard values. So first parameter already will be color, odor, taste. So according to USPHS, it should be colorless, odorless, and tasteless. ISI standards will not define it. The second one, pH. So USPH it is not defined pH. ISI standard was determine the pH of a fresh water. So fresh water should be contain the pH value 6 to 8.5. If the water contains 6 to 8.5, then it is a good quality water. Next, if you observe the dissolved oxygen, DO, we will discuss next also clearly. So DO value should be according to USPH value, PHS value 4 to 6 ppm. 4 to 6 ppm means parts per millions. ppm means parts per million. It is the unit for measuring dissolved oxygen. But according to ISI values, it should be 3. According to USPHS, DO value should be 4 to 6 ppm, but ISI value should be 3 ppm. Next, TDS, total dissolved solids. TDS value should be total dissolved values. TDS value should be 500 ppm. So 500 ppm should be present in the water per 1 liter. So but ISI standard will not define it. So it don't have TDS value. Next, suspended solids, TSS value. It should be 5. ISI standard is not defined it. Next, chlorides. Chlorides should be present in 250 milligrams per liter. 250 milligrams per liter. So ISI standard value, it may be 600 milligrams per liter. Next, sulfates. Again, sulfates also present in 250 milligrams per liter. But according to ISI, it may be 1000 milligrams per liters. Next, chlorides. if you observe the fluorides in 1 liter of fresh water, it may be 1.5 milligrams per liter, but it should be contained only according to ISI values. It may be 3 milligrams per liter, like that. Next, ammonia 0.5 milligrams, ISI standard value not defined yet. Next, calcium 100 milligrams per liter, ISI standard not defined. Magnesium 30 milligrams per liter, it is not defined, ISI standard values. Next, arsenic, if you observe the arsenic, it should be 0.05 milligrams. Next, according to ISI standard value, it should be 0.2 milligrams per liter. Next, COD, chemical oxygen demand, it should be 4, but ISI standard value it is not defined. Next, phenols, it should be 0.001 milligrams per liter. Next, ISI standard values 0.005. Next, pesticides, it should be according to USPHS 0.005 milligrams per liter, but it's in ISI is not defined yet. Next, lead less than 0.5 milligrams per liter, but it's according to ISI 0.01. Mercury, it should be 0.001, but ISI is not defined. Zinc 5.5, but ISI not defined. Like that way we can observe some parameters to indicate water quality. Whenever we observe these parameters in the given water sample, then it is a good water. Otherwise, if the parameters are not followed according to these values, then it is a polluted water. Then we can estimate that it is a polluted water or treat as a polluted water. This is about quality of water. Next, some more properties of quality water I will discuss next video. Dissolved oxygen, chemical oxygen demand, biological oxygen demand, and also hardness of water. All these are the some more parameters of water quality. We will discuss in next video.